Everyone. Today we'll be discussing the LeetCode problem of the day, count mentions per user. So here you're given an integer number of users and an array events of size n, 3. So you have a array which is list of strings of size n rows, and in each row you have a list of string which is of size 3. So this list of string will contain 3 strings. So that list of string is of two types, type 1 and type 2. So let's see each of them together. So type 1 list string can be as follows. Please. And for type 2, you can have it as follows: offline, timestamp, and ID. So this type 1 means you have a message which is coming at timestamp I, and mentioned string of I represents all the users that will be mentioned at this timestamp I. And again, this mentioned string of I can be split into 3 parts. So first, it can be of the type ID number. So that means this string can be something like this: ID 0 is ID maybe 2, ID maybe 4, and so on. So this can be a string with all the ID numbers separated by a space. Or this string can also be just the word all. And this string can also be just the word here. Sorry. So if you have this type of the mention string, that means all the IDs mentioned in the string, all the IDs in the string will be mentioned once at this timestamp. And all represents all the users, all the number of users will be mentioned at this timestamp I. And here represents only the online members at the particular timestamp will be mentioned. Let's discuss the input later, then it will be clear what the online and offline means. And there's an offline type of list of string, which means that at timestamp I, this ID person will be made from online to offline. And suppose the person is made offline at timestamp 30, so he will be offline from timestamp 30 till timestamp 30 plus 60. So that means whenever you make a person offline, he will be offline for total 60 minutes. So at the end, you just have to return the array mentions, where mentions of I represent the number of times each ID, each user is mentioned across all these message events. And initially, all the users are online. And if a user goes offline and comes back online, their status change is processed before handling any message. So suppose at timestamp 60, there is a message, and at timestamp 60, some person state is changing from offline to online. So first, his state will change to offline, from offline to online. Then only the message at time 60 will be processed. Also, it is note that a user can be mentioned multiple times in a single event. So that means in this, we have ID 0. So we can also have ID 0 again, then ID 4. So you can have multiple users in the mention. So let's see the examples. So in the first example, we have number of users equal to 2. So ID 0, ID 1. These are the two users. And initially, both are online. So I'll just mention this person is online, person is online. And the number of mentions are 0 so far. So first, we have a event of this type: message at timestamp 10 and ID1 and ID0. So that means at t equal to 10, we are mentioning the person with ID1 and the person with ID0. So ID0 will be mentioned once and ID1 will also be mentioned once. The mentions count will increase for both of the users since we mentioned both of the users. After that, at t equal to 11, we have a query of the type offline. So the user number 0, we are making him offline. So user number 0, he will be offline until since he is made offline at t equal to 11, he will be offline till 11 plus 60, that is till 71. Till t equal to 71, he'll be offline. So this query is done. Next, we have a message at t equal to 71 and here. So we have the timestamp equal to 71. And here in the sense, we will mention only the online users. But we see that at t equal to 71, this user comes back from offline to online. So first we make him online. And since we want to message all the online users, so both the users are online. So the mention count will increase by 1 for each of them. So at the end of all the messages, the both the users will be mentioned 2 times. So the output is 2, 2. Now let's look at the second input. So here again, we have 2 users, user ID 0, user ID 1, and initially both are online, and the mentions count for both of them is 0, 0. So first you have a message at t equal to 10 for ID 1 and ID 0. So both of them will be mentioned once. Next, there's an offline for user ID 0 at timestamp 11. So since the user 0 is made offline at t equal to 11, he will be offline for 60 minutes. So that means he will be offline till timestamp 71. Next, you have a query message all the users at t equal to 12. So at t equal to 12, you want to message all the users. But note that even though the user 0 is offline until t equal to 71, since you are messaging all, so no matter if the user is offline, you will still mention him. So mention count for 0 will increase by 1, mention count for user 1 will also increase by 1. So the final output is 2, 2. Now let's look at the third input. So here again we have 2 users, 0 and 1. Initially both are online and the mentions are 0, 0. So here you have the first t equal to 10. You are making user 0 offline. So user 0 becomes offline till time 10 plus 60. So till 70 timestamp, he will be offline. Next, you have a query message, which is coming at t equal to 12. And you are messaging only the here. That means you will message only the online users. So at t equal to 12, this user is online, but this user is offline till timestamp 70. So 12 is less than 70. So this user is still offline. So you won't mention this user. So only for this user, the mention count will increase. And the queries are done. So the output will be 0, 1. Coming to the constraints, it's pretty small. So number of users will be 100. And the event's length will be also 100. And events length of I, of course, will be 3. And events of I, in that list, the first one will be either message or it will be either offline. And the events of I1, which is the timestamp. So timestamp will be less than 10 power 5. And the number of ID mentions in any message is between 1 to 100. So if we have this type message ID 1, ID 0, and so on. So this will be at max 1 to 100. And it is guaranteed that if a user is referenced to be offline, that means before this he was online for sure. Then only we will call this query to make him offline. Now let's go over the approach. So the approach is basically doing the simulation of all these queries. So let's see how we can do that. So I'm taking this example where number of users equal to 3. So for that, first I'll create a timestamp array. So this is for user number 0, user number 1, user number 2. And initially all their values will be -1. So -1 uh, represents all the users are online. So we are taking -1 because here the timestamp is starting from 1. So any timestamp which is less than 1, so -1 is less than 1, so we can say this is for to represent the online users. So let's keep this aside. And also we'll keep an array to count the mentions. Index 0, index 1, index 2. And initially all will be 0. So now the first query is at timestamp 1, you have to make the person 0 offline. So person 0 is made offline at t equal to 1. So he will be offline till t equal to 61. So in this timestamp array for user 0, I'll mark him as 61. So 61 denotes till t equal to 61, he will be offline. And after 61, he'll be online. Next, you have a query again offline at t equal to 2, but for the user 1. So user 1 was online. So he will be offline till t equal to 62. So these are the two queries so far. After that, you have a message query coming at t equal to 2. So t equal to 2, you have to message and here. So here indicates you will message all the online users. So to check the online users, you just iterate on all the users and compare their timestamp with the current time. So current timestamp is 2. So this fellow's timestamp is 61. So 61 is greater than 2. So he's offline. 62 is also greater than 2. So he's also offline. Since -1 is not greater than 2, that means this person is online. So we'll increase the count for this person. After that, we have again a message query coming at t equal to 61. And it is asking to mention all the online users. So again, we'll iterate on this. So first we'll see here that at t equal to 61, first this fellow will be converted from offline to online. So we can say something like if user, if online time of a particular user, if it is less than equal to current timestamp, that means he's online. So in this case, 61 is equal to 61. So he is online. So we'll increase the mention for this user. Now for this user, online time is 62, but timestamp is 61. So this is not true. So this user 1 is still offline. Now for the third user, timestamp -1 is less than 61. So he is also online. So we'll mention the user 2 as well. So after processing all these queries, the output is 1, 0, and 2. In this, let's take one more query. I'll write it at the bottom. Suppose we have something like at t equal to 64, we have all. Then at t equal to maybe 68, we again have all. So when we have the query of type all, that means we have to mention all of the users. So instead of iterating on all the users every time we get the all type of query, we can just keep a track of how many times the all is called. Suppose in this case, the all is called 2 times. So once the processing is done for the entire array, so in this case, the answer is 102. After processing the answer, after processing all the messages, we'll just add the all to all the users. So since all is called 2 times, so we'll add a +2 to all these users. So the final answer will be 3, 2, and 4. So this is just done to reduce the complexity. So instead of iterating all the users each time whenever we have all type of query, we'll first calculate how many times this all is present, and we'll just add all of them only once. Now let's code the approach. So since this is a problem of implementation, the approach will be a bit more clear once we are done with the implementation. So first let's take an integer array to store the answer mentions. Size will be equal to the number of users. And also I'll create an array which will store the online time. This will also be number of users. So initially we are setting online time as -1 for all the users. So we will do arrays.fill. Arrays.fill online time -1. So initially all the users are online. Now let's iterate on the events. So now we have a particular event, list of string events.get of I. So the event is a list of string, and like we discussed, it can be of 2 types, either the offline type or the message type. So first let's write 2 cases for that. So if event dot get 0 dot equals message, then it's a message type, else it's the offline type. So first let's deal with the offline case. So in the offline, we have timestamp. We need to extract the timestamp, and we also need to extract the ID. Since they are in string, we first have to convert them to integer. So we can have timestamp equal to integer dot value of event dot get 1. So in event dot get 1, we have the timestamp. In event dot get 2, we will have the ID. So we can say ID. And once this is done, we just need to set the online time of this person. The online time of ID will be timestamp plus 60. So that means this person ID will be offline till timestamp plus 60. So the offline case is done. Now let's deal with the message case. So again, like we discussed in the message case, okay, first let's extract the timestamp. So we can use this. And let's also first extract the message string equal to event dot get 2. So like we discussed, this message, this mentions string can be of 3 types. Type 1 is set of users, ID0, ID1, ID2, and so on. Next, it can be all, and next it can be here. So let's write separate cases for all of them. So if mention string equals all, then like we discussed, I'll just take a variable int all to track how many times the all is called. So if it's all, I'll just increase this variable. Next, let's have if the mentioned string is equal to here. So if it's equal to here, then we'll just iterate on all the users who are online and increase their count. So let's run a loop. Less than number of users plus plus. So for a particular person to be online, we just need to check the online time. Online time of a user is less than equal to time stamp, then he's online. So we can just increase the mentions of that particular person. So the here case is done. Finally, we are at the case where the integer, the string is of type id0, id1, and so on. So for example, it will be of this type. So for that, first we have to extract all the strings individually. So we can say string array IDs. We can do string dot split. So mention string dot split at a space. So whenever this space, each of the string will be split into strings array. So once we have the strings array, we can just iterate on the strings array, string ID in IDs. So first let's convert the ID into integer. So we can copy this. Integer dot value of ID. So we got the ID, and once we got the ID, we can just increase the mention of this ID. Mentions of ID plus. So this is the case. This case is also handled. At the end, since we are tracking the all count separately, so we can just iterate on the users again. 0 I less than number of users I plus plus, mentions of I plus equal to all. So let's test it. Okay, dot. Right. I forgot to return. So return mentions array. Also, there's one thing here. In the message, we have the string as type id1, id2, and so on. So it is like the string is of the form I, D, and then we have the number. So when we do integer.value of, we have to skip this id part and just pass the number part. So for that, we can do substring, and this will start from index 0, index 1, index 2. So from index 2, we will have the actual number. So when we do this, we are ignoring ID and we are only passing the integer value. So now, okay. But one thing to note that it is nowhere mentioned that all the strings will be given in sorted order based on the timestamp. So we first have to sort the events based on the timestamp. So let's quickly do that. Collections.sort events, and we'll define a new comparator. Of string compare. When comparing, we have two list of strings. Override. So while comparing, if the timestamp is not equal, then the message which has the least timestamp will be sorted first. So for that, first let's fetch the timestamp. So we can just copy this. So time A is integer dot value of A dot get 1. And similarly, we can do it for time B, B dot get 1. So if time A is not equal to time B, then we can just return integer dot compare time A comma time B. So whichever time is smallest, that event will come first after the sorted array. Now, what if there's a tie? So in the else case, when the timestamp is same, so the query of the type offline should be given first priority. Only after that, the message query should be given priority, because I think somewhere it's mentioned that let me check. Yeah. So here all the users are initially online, and if a user goes offline and comes back online, their status change is processed first before handling any message. So when we do the sorting and when the timestamp is equal, first we process the offline the status change query. So here we can say that if a dot get of 0 is equal to offline, then this will be given priority. So for this to be sorted first, we have to return -1, and else we return 1. So this is the sorting. Let me test it again. I think I need a semicolon here. A bit. Yeah. Let me. And it works. Finally, let's do the time and space complexity analysis. So first we are sorting the events list. So sorting will take time order of n log n. So this is n log n. And after that, we are iterating on the event size, which is order of n. And inside it, inside this, we have two cases. So in the first case, we are just increasing the constant variable. In the second case, we are iterating on the number of users. So this will be order of the number of users. And in the else case also, I think we are iterating on the IDs. So this also can be order of the number of users. And I think in the else case also, in the else case, it's just constant because it is just for a single user. So this is order of n, and inside this, we are running a loop. So this will be order of users. And at the end, this for loop is also order of users. So if we add all of them, it will be n log n plus n into users. So the time complexity will be order of log n plus n into users. So we can say order of n into log n plus users. Take it common. Yeah. And now coming to the space complexity. So for space complexity, we are creating two arrays. So one is for the output, but we are creating another array for the number of users. So the space complexity will be order of users. I also have the code in Python if anyone wants to view it. I'll add this in the description as well. And let's catch up in the next video.